The Southern Ocean, a realm of icy beauty and unforgiving conditions, holds a secret: the Antarctic Circumpolar Current, or ACC. This powerful current, a continuous flow of water that encircles Antarctica, is a vital artery of our planet's climate system. It connects the Atlantic, Pacific, and Indian Oceans, playing a crucial role in regulating global temperatures and sustaining marine life. Few people are aware of the ACC's existence, yet its influence is felt worldwide. Like a giant mixer, it churns the ocean, distributing heat, nutrients, and oxygen. This continuous movement is essential for the health of our planet, influencing weather patterns, ocean currents, and the delicate balance of marine ecosystems. The ACC's role in carbon sequestration, the process of capturing and storing atmospheric carbon dioxide, is particularly crucial. By absorbing vast amounts of CO2, the Southern Ocean acts as a massive carbon sink, mitigating the effects of climate change. This function alone makes the ACC a critical player in our planet's future. However, this vital current is facing a growing threat: climate change. The warming of our planet is causing the Antarctic ice sheet to melt at an alarming rate, pouring fresh water into the Southern Ocean. This influx of fresh water is disrupting the delicate balance of the ACC, slowing its flow and potentially impacting its ability to regulate our climate. Subscribe, like, and share Cosmo Academia. The Antarctic Circumpolar Current, ACC, is Earth's strongest ocean current, driven by winds and Earth's rotation. It connects major oceans, regulates global temperatures, and supports marine life. However, climate change threatens this vital system, altering its flow and balance. The ACC's strength and connectivity are crucial for Earth's climate stability. The Antarctic ice sheet, a vast expanse of ice and snow covering the Antarctic continent, is a key player in the Earth's climate system. It holds the largest reservoir of freshwater on Earth, influencing global sea levels and ocean circulation patterns. The ice sheet plays a crucial role in reflecting sunlight back into space, helping to regulate Earth's temperature. However, this frozen giant is highly sensitive to changes in temperature. As our planet warms due to human-caused climate change, the Antarctic ice sheet is melting at an alarming rate. This meltwater flows into the Southern Ocean, disrupting the delicate balance of the ACC. The influx of fresh water reduces the salinity and density of the surface waters, making them less likely to sink. This disrupts the normal process of deep water formation, a key driver of global ocean circulation. The ACC, powered by this circulation, is therefore affected by the changes in freshwater input. The consequences of a slowing ACC are far-reaching. It could disrupt global heat transport, leading to more extreme weather events and altered climate patterns. This highlights the interconnectedness of Earth's systems and the delicate balance that sustains our planet. To understand the potential impact of a slowing ACC, we must delve into the complex world of oceanography. The ACC's strength is driven by a combination of factors including wind patterns, the Earth's rotation, and the density differences between water masses. Freshwater, less dense than saltwater, disrupts this delicate balance. As meltwater from the Antarctic ice sheet enters the Southern Ocean, it creates a layer of less dense water at the surface. This stratification, the layering of water masses with different densities, hinders the mixing of surface and deep waters. This mixing process is crucial for the ACC's strength. As denser, saltier water sinks near Antarctica, it draws in warmer surface water from the north, driving the current's flow. However, the influx of fresh water weakens this process, slowing the sinking of dense water and reducing the ACC's overall strength. This disruption to ocean circulation has far-reaching consequences. The ACC plays a vital role in transporting heat, nutrients, and oxygen throughout the world's oceans. A slowdown could have significant impacts on marine ecosystems, global climate patterns, and the ocean's ability to absorb carbon dioxide.
Subscribe, like, and share Cosmo Academia. Recent studies confirm the Antarctic Circumpolar Current, or ACC, is slowing down. This powerful current regulates global climate, transferring heat from the tropics to the poles. A slowdown could disrupt heat transport, intensify extreme weather, and harm marine ecosystems, threatening biodiversity and fisheries. It's a clear signal of climate change's impact.
Section 6. The Domino Effect, Global Climate Change. You see, the slowdown of the ACC is not just an isolated event, it's actually a symptom of a much larger problem: global climate change. The warming of our planet, driven by human activities that release greenhouse gases into the atmosphere, is causing widespread changes in Earth's climate system. The melting of the Antarctic ice sheet is one of the most direct consequences of this warming. As temperatures rise, the ice sheet loses mass at an accelerating rate, pouring fresh water into the Southern Ocean and, disrupting the ACC's delicate balance. This disruption, it's like a domino effect, impacting global climate patterns in ways we're only beginning to fully understand. The ACC plays a crucial role in heat transport, regulating temperatures around the world. But with a weaker ACC, we could see more extreme weather events, heat waves, droughts, floods, because heat is distributed less efficiently. And here's the kicker. A slowdown in the ACC could actually accelerate the melting of the Antarctic ice sheet. Warmer water would reach the base of the ice sheet, increasing the rate of melting, and we'd be right back to square one with even more fresh water pouring into the Southern Ocean. It's a vicious cycle that we need to pay attention to.
Section 7. Echoes in the ecosystem, disrupting marine life. The Southern Ocean might seem remote and desolate, but it's actually teeming with life. From tiny plankton to gigantic whales, so many creatures depend on its frigid waters to thrive. And the ACC plays a huge role in sustaining this ecosystem, influencing the distribution of nutrients and even the migration of species.
That's right. The ACC acts like a barrier, keeping different water masses separate and creating distinct habitats for marine life. But if the current weakens, these water masses might mix more easily, displacing species and, honestly, throwing food webs out of balance. It's a delicate system, and even small changes can have big impacts.
Plus, the ACC is critical for nutrient cycling. It helps bring nutrients up from the deep ocean, which is essential for supporting the growth of phytoplankton, the base of the marine food web. If the ACC slows down, this upwelling could be disrupted, and that would mean less food for the entire ecosystem.
The consequences could be severe. Species distribution, abundance, food web dynamics, they could all shift dramatically. Fish populations might decline, and that's not just bad for marine life. It's bad for fisheries and for the people whose livelihoods depend on them. The Southern Ocean's delicate balance is truly at risk.
Subscribe, like, and share Cosmo Academia. Section 8. A carbon sink in Jeopardy. The Southern Ocean plays a critical role in mitigating climate change by absorbing vast amounts of carbon dioxide from the atmosphere. This process, called carbon sequestration, is essential for regulating Earth's climate and slowing global warming. The ACC is a key player in this process. Its circulation patterns help move carbon dioxide-rich surface waters down into the deep ocean, where the carbon can be stored for centuries. This natural carbon sink acts as a vital buffer against the effects of human-caused greenhouse gas emissions. But here's the concern. A slowdown in the ACC threatens to weaken this carbon sink. If the current circulation slows, it could lose some of its efficiency in transporting carbon dioxide to the deep ocean. That could lead to a buildup of carbon dioxide in the atmosphere, which would, unfortunately, accelerate climate change. It's a troubling feedback loop. The ACC slows down because of climate change, but that slowdown could, in turn, make climate change worse. It's a stark reminder of just how interconnected Earth's systems are, and why addressing the root causes of climate change is so urgent.
Section 9. A call to action, our collective responsibility. The slowdown of the Antarctic Circumpolar Current is, it's a stark reminder of how interconnected Earth's systems are, and how profoundly human activities are impacting our planet. It's a call to action, urging us to tackle the root causes of climate change and protect the delicate balance of our oceans. Reducing greenhouse gas emissions has to be a top priority. We need to move away from fossil fuels, embrace renewable energy, improve energy efficiency, and adopt sustainable practices in every aspect of our lives. It's a big task, but it's one we can't afford to ignore. And we can't stop there. Continued research and monitoring of the ACC are absolutely critical. We need to understand its complex dynamics and its role in Earth's climate system better. That knowledge will help us develop effective strategies for both mitigating and adapting to these changes. The future of our planet really depends on what we do now. We have to act right now to protect the ACC, the Southern Ocean, and the delicate balance of our planet for future generations. The time for sitting back is over. Let's rise to the challenge and create a sustainable future for all. And don't forget to subscribe, like, and share Cosmo Academia. Together we can spread awareness and inspire action.